Hey everyone, so this is a video for section 2.2, elementary functions, graphs, and transformations. So a majority of this section, hopefully you have experience with Desmos, using Desmos, graphing things. A lot of the questions in the notes that we'll go over and the homework questions will ask you to check with graphing or graph this, what would the graph look like. So please use Desmos. For a lot of the questions we did at the beginning with the domain and range stuff, make sure you use Desmos as well. So one of the beginnings here, it talks about there are 6 functions. There's the identity, and then there's the square function, which is x squared. There's the cube, x cubed. There's the square root. You have the cube root. And then we have the absolute value, which is this vertical bars. So all of these, it has a picture accompanied with it. You can also graph these on Desmos. So for each one of these, it wants you to talk about what is the domain and range. So just think domain is just all possible input values. Right? And you can think of this as your input as pretty much your x, like what are you plugging into the equation? Okay. And you might think, well, can't you plug in everything? Well, remember there are certain functions where I can't have maybe zeros in certain places, like if you're dividing. Like for instance, if we looked at 1 over x as a function, I can't divide by 0. So in this case, for this particular function here, my domain would be I can plug in any number except for 0. Okay. Some of the other ones that are kind of restrictive at the beginning, if you had, we'll talk about if you had square root function, that's a little bit restrictive. Okay. So just think domain, all possible input values. So for the identity function, all reals. So it's usually an R with the 2 vertical lines. That means all reals. That means any possible number I can plug in. And in interval notation, it is listed as this. Okay. And for any identity function you have, if I plug in anything, it's gonna be the same thing I plug in. So if the domain is all reals, the range is the same. It's going to be all reals. Let me think, what is the range? So the range is all possible output values. Okay. So you want to think domain is just thinking about what can I plug in for x. Range is what am I going to get out. So some people think of this as your f of x values or your y values. What are all the possible y values? So just remember, if you look at this picture here, we see that this is your graph of f of x equals x. So the domain is, well, it looks like the line keeps going to the right, it keeps going to the left. So it kind of quantifies that the domain is everything because I'm going to the left, I'm going to the right, I'm not leaving out any values. And likewise for the range, you can think, oh, it looks like it's going up on this side, looks like it's going down on this side, so it's going to be all the possible y values. So you can quantify that domain is, if I go look from left to right, does it look like I'm touching anything? Is my function going to keep kind of going in that general direction? Okay. So for the squared function, you'll see that it looks like if I drill on this, it looks like my function is going to keep going this way, and it's going to keep going this way. So it's not really going up on both sides, like exactly up, as in like this. It's going at a slightly to the left, slightly to the right. So for this, your domain would be all reals again. Okay. So if you think about it, what does it mean intuitively? Can I take any number and can I square that number? And the answer is yes. I can always take any value and square it. So that's why I can plug in any number here. But when I square any number, what happens? So you can recall that any number that you squared will not be negative. Okay. So the range for a squared function is going to be different. Sometimes you have to graph it to see, because this graph we'll talk about in the section, if I shift it up or down or do some reflection, it's going to be changed a bit. So the range for the general case is, it's not negative, so non-negative. So it can be 0, including it. Right? So you can think from a visual standpoint, domain left and right, it looks like it's going to the left here. Looks like it's going to the right, so all reals. For the range, I don't have anything down here, right? There's nothing down here in my graph. So I say it starts at 0 because that point here, and it goes up. So 0 into infinity, including that. For the cubic, you see that it's going down, and then it's going up like this. So it looks like it's not completely down or completely up. It is slightly to the left and slightly to the right. So this is a great case of the domain and the range are both all reals. Okay. So cubic and the identity function are very nice examples of the domain and range will typically be the same, all reals for both. The squared function does have a quirky thing for the range, and you'll see for the square root, this will have some weird sort of restriction as well. So you already see that just from the basic graph, we start at the origin and we're going this way. So we see that we're not going to the left. So your domain from the basic one is positive and 0. And then the range is also positive, right, or 0, because the square root is 0. Okay. We see we don't have anything down here, like there's nothing there, and there's nothing over here. So you could graph one of these on Desmos and you might see something weird about it, and we can look at one of those. So, and then we have the cube root, which is kind of like the cubic, but you'll see what happens. It's going to the left and a little bit down, and then it's going to the right and a little bit up. So really nice example of I can pick anything for the domain and anything for the range. So this is just the cube root. So this is the domain and the range are all reals. Okay. And then lastly, we have the absolute value. So it looks like a squared kind of, except instead of curved, it's flat. It looks like a triangle. So domain would be, I can plug in any value and get the absolute value. Remember, absolute value is the distance from 0. So how far is this number from 0? So the domain would be any number. And then the range is 0, including it, to infinity. So you want to think, if you're talking about a distance, distance is positive, but if you're at the point, it would be 0. So we include that. So practice some of these, especially on Desmos. Some of the very first questions on your MyLab will ask you to find the domain and range of a function. You could try to do that by hand, but that's very difficult. I would stress use Desmos, graph it on Desmos, get a picture, and then see if you can, from that, what would be the range, what would be the domain. Okay. And think for a lot of them as an absolute value. Cube, root, cubed, quadratic, and identity, the domain is the same. It's all reals. The ones that are kind of weird for the domain is the square root. So where does it start? And does it go to the left or to the right? So for this part here, I want you to evaluate each one, which for some of the homework problems you don't really need to evaluate, but we can go over how to do that, just to refresh our memory. So it wants you to evaluate each one at, so remember we have our 6 functions. we have the identity, quadratic, cubic, we have square root, cube root, and then the absolute value. Now, I did different function names, so F would be for the linear one, or sorry, identity. G is for the quadratic, H is for cubed, and then I is for square root, J is for cubed root, K is for absolute value. Okay. So just think, for instance, if I wanted to find F of 64, this would just be using my definition, so that's just 64. G of 64, which would be using the quadratic, would be 64 squared, which is a rather large number. Okay, so let's see what this would be in our calculator. So 4,096. And then we have H evaluated at 64, which is even larger. So please use Desmos for any calculations. Double check to make sure you can type these in. H of 64 would be square root of 64, which is just, in this case, 8. J of 64, which is evaluating the cube root. So this one is a little finicky. So cube root of 64. So if you do the third root here, just get 4. So practice that with Desmos, okay? One thing to, if you want to rewrite this, you can do 64 right to the 1/3 as your power. That works as well. And then K is 6 of 64. Absolute value. How far is 64 from 0? It's 64 units. Okay. So this next one here is just this number. So make sure for B here real quick. Typically, in my experience, the only one is that if we just go through this one real quickly, there are a few it won't work for. Okay. So F of negative 12.75 is just negative 12.75. It's just the same thing. So identity, whatever you plug in, will be your same output. Okay. Now this could change if you shift the identity function left or right, up or down, or stretch it, which we'll talk about because this section also does transformations. G of negative 12.75 is negative 12.75 squared. So you'll need your calculator for that. Let's see what we get. So you get this really large number. We raise it to the second power. And we have H of negative 12.75. So that's cubed. So I'll just show you on Desmos how you do this. So let's open Desmos. So I have stuff from before, so we can just delete some of these things. Okay. All right, so let's type in that number. So parentheses, negative 12.75, close parentheses. And then I want to do it to the third. So there's a button that has like A to the B here, right here. Let me click on that. Right. And then put your cursor up there, and then we're going to say 3. So we get that wonderful value here. So negative 2072.67. Okay. So approximately negative 2072. So I rounded it a bit. I to the, so this is we're talking about the square root of a negative number here. So you might recall that you can't take the square root of a negative. Let's see what Desmos gets for this one if we take the square root. So if you see here that if I do square root and then negative 12.75, what do I get? I get undefined. So that means it doesn't work. I can't plug it in. Okay. Okay, so undefined. It does not exist. But fortunately, if you want to do the cube root, remember a cube root typically has no restriction. You can plug anything in. So let's look at Desmos for that. So you'll notice here that there is no cube root, even if I look at any of these other pages. So what you want to do is you need to rewrite it. So remember, the cube root is the 1/3 power. So parentheses, negative 12.75, close parentheses. Do your raised to what power and do your 1 divided by 3. And what do we see? Negative 2.336. So it's approximately that. And last but not least, how far is this from 0? Well, it's just going to be 12.75 units. Because remember, that is what absolute value is. So hopefully evaluating some of these were beneficial. Just remember, you can use Desmos for evaluating. So match problems here if you want to practice. And then it kind of shifts to horizontal and vertical. Okay. So one thing I want to say is that if you were, like for instance, what's the domain and range? For instance, let's look at one of these that you might struggle with on your homework. So let's say we want to graph something. So let's look at a square root since that one seems to be, so let's say our equation is f of x equals 5 minus 2 square root of x. And so if you see this, what do you notice? You zoom out a bit, drag your fingers if you're on your iPad and so forth. So you want the domain. Okay, so I can't draw on Desmos, unfortunately, but if you think about it from left to right, where does it start? Where do you start seeing the function? So if I click on the function, it looks like it starts there at 0, 5. So for this, my domain would be, I'm starting at 0, and I have everything to the right because my function is going to the right. So domain would be 0 including to infinity. Okay. So you can think your domain, just write it out here. I don't think I have brackets. I do. I can't do that. So it's a little finicky for what it will let me do on this. So you can think it's 0. I can't do infinity here. That's fine. Let's see. Oh. Just going to write it here. I'll just type in this. And then, so it'd be 0, not to negative infinity, but positive infinity. So instead of infinity, you would have to write the little symbol here, the little curly 8 on the side. But for this is the domain. But you'll notice, what about the range, right? So the range, right, in this case, you want to see it looks like it's starting at this high point here at 0, 5, and then what? Everything below 5 I'm including because it's going downward. So your range will be, I have everything at 5 and below. So that would be negative infinity to 5. So just to reiterate from before, this is just like some extra practice. So domain, of this function here, okay, of f of x equals that. So we said the domain would be 0 to infinity, and then the range is negative infinity to 5. Okay. So always look at your graph first. Don't try to do it by hand, right? Use Desmos. I know that in high school, middle school, you might have done this, and it could have been without a calculator, which is really difficult. Domain and range are sometimes a visual concept that can be easy to get if you see the graph. So now we'll talk about if we have graphs, can we somehow shift them, or if we had a function, and if we added a value or added a value into the x, what's going to happen? So you'll see here that when I take a function and apply something to it and get something new, it's called a transformation. Okay. So if a vertical transformation, if I add a number to the outside, this is a vertical transformation. If it's positive, then I will go up. Okay. And likewise, you can think if it's negative, what's going to happen? It talks about it here as well, an example. Okay. So one thing you want to think, if I have some graph, let's say f of x equals, let's see what you have on your homework here. So one of the questions is, suppose you have f of x equals, let's say the original is f of x, and now you have f of x plus 3. What is that? How would that change from the original? So this just means you go up 3. The whole graph will shift up 3. Suppose if I have this and I subtract 4 on the outside, that means the whole graph will shift down 4 units. So what this is talking about, what happens is if you're looking at the graph. Okay. Now the next part talks about horizontal shifting. If I actually, you'll see if I add it to the inside. So let's say if I have like this, plus 2 on the inside. So the inside thing is opposite. Okay, always think inside is opposite. Outside is the same. So because this plus 2 is on the inside, well, you think, oh, that means I'm going to go right 2, but think opposite. Okay, note that this is the opposite of what you might expect. So this actually means I go left 2. And then if you had something like this means you're going to go right. The whole graph will shift right 5. Okay, and you have some of these in your homework where it says this is the graph of f of x. It doesn't give you an equation. What would your new graph look like? Okay, so do be aware of how they work, how the left, right, up, and down works. Okay. So for instance, what happens here? If I have this absolute value, what would my new graph look like? So that means I'm just going to shift everything up 4. It would go up 4 units. So it would look somewhat like 1, 2, 3, 4, somewhat like this. Okay. Shifts up 4 units. Okay. What about this one? If I have a minus 5 on the outside, well, that will just take it and that will shifts down 5 units. Okay. And you can always graph this. I would say it's very good to graph the original if you have the function and the shift. And then you can kind of see, oh, this one is this one moved down. Okay. Now for some of the homework questions like up here, it's just going to say if you have f of x, what would this do? Well, you don't have an f of x. You just have some idea of f of x. So you can't really graph anything here. So likewise here, it talks about some horizontal shifting. This is very good, as I say, graph it on Desmos. Okay, so let's look at this one and we'll graph it on Desmos. How does the graph of this relate to y equals f of x? I mean, y equals absolute value of x. Let's go over here. Let's key it in. So let's do y equals absolute value of x. So the absolute values, they see the double bars here with the a on the bottom left. Okay. And then let's graph the next one. So you see here the black line is do x minus 4. And what happened? Well, the red line is some units to the right. And you'll notice this looks, I think it's 2, but it's 4 because I'm zoomed in. So in Desmos, we see that minusing 4 on the inside does what? Shifts it to the right 4. Okay. And likewise, you could do the other one. Sorry, that meant plus. I need to switch it back then. That's my mistake. So I thought it was a minus there, but it's actually a plus. So the plus 4 does what? It will shift it to the left 4. Okay. So make sure, double check that you don't switch your sign like I did. So this shifts left 4 units. And this one down here, you can check on Desmos. This will shift right 5 units. Okay. And there's a match problem here, so you could double check how does the shifting work. Okay. And this one just goes through write appropriate equations. Okay. So you think, what is the correct way that I would change the original, which is your f, right? So you see here's f and here's f, the blue one. So you'll see h is what? H is from the blue, it looks like I go up 2. G is what? Looks like I go down 4. M looks like I go 1, 2 to the left. And N looks like I go 3 to the right. So how would I write these? Okay. So for h of x, big H of x, if I go up 2, that would just be the function adding 2. So for g of x, if I go down, it's just the same function, but then I go down. Because remember, up and down, vertical shifts are outside, so you're adding those on the end. For horizontal shifts, like for m, okay, that's when you have to change the inside. All the x's get modified. Okay, so we only have one x here. So that x is modified now. Instead of x, I need to write, if I go to the left 2, for every x, I put x plus 2. And then I need to square it. Okay. So you want to think for this x squared, this x is now going to be whatever you have. It's going to be squared now. Okay. And then for your n, since I am going right 3, it's going to be a minus 3 on the inside with your x. There could be a match problem here, so you can practice this. Okay. Last part of the transformations is it does vertical stretching. And you might wonder, is there horizontal stretching? There is, but we're not really going to cover that. That's like pre-calculus, calculus stuff. We're not going to cover it in this course. So it says here, if you want the graph of some number times the original function, we take this and we multiply it by, so a times this. So you see a is on the outside. So that means that a is really just changing the y value. So that means what? You're going to have a vertical stretch or a shrink. So the y values will change, the x values will stay the same. Okay. And if a is a special number, -1, it reflects over. So it's pretty much going to shift it all the way to the other side. Okay. So we can see that here. I go to Desmos. Right, so we have, here's our, right. So let's say I have y equals, and let's put a 3, and then let's do absolute value of x. What do you notice? It stretched it. So instead of being at 1, 1, right, or -1, 1, and +1, 1, it's what? it went all the way up to this. So one thing I want to show you is on Desmos you can do this really nice thing. So let's say I put an A here. I can add a slider. So when A is 1, it looks the same, right? Well, what happens? You see that as A gets larger, it's having a more stretching thing, and vice versa. So if we made it a -1, it looks like it's reflected over that. Okay, and you'll notice what happens when A is between 0 and 1. It looks like it's being smushed. So that's a vertical shrink. So all your Y values are being smushed. So instead of going through, in this case, if I put it at a half, instead of at 5 being at 5, you're actually going to be at 2.5 because that's a half. So these slider things are very useful. Okay. And you can do the sliders anywhere. So for instance, if I wanted to put the slider on the inside, if I wanted to put plus A, add a slider, what happens? Oh, it shows my graph changing as I'm changing that value. So this is very useful. You can play around with it if you'd like. It's up to you. So I can't tell you how much that this section is very useful. Desmos is extremely useful for helping you graph to see things. So how does the graph of this relate to the graph of this? So you notice there's a 2 in front. So remember, if there's a 2 being multiplied, that means it's a vertical stretch. So vertical right? So just think, if it's bigger, it's a vertical stretch by 2. You want to think all Y values double because it's multiplying by 2. X values stay same. Okay, so kind of just looks like instead of at 1, 1, we're at 1, 2, and so forth. So you kind of eyeball it and you double it, and it should look something like this. I'm not the best artist, okay, but it looks somewhat like that. It'll be more stretched vertically. And likewise, what do you think this one's going to do? It's going to shrink it vertically. So it's going to look a little bit shrunk, somewhat like this. So vertical shrink by 1/2. Okay, so we're shrinking all the Y values by a half. Okay, so all Y values shrink by 1/2, and the X values stay the same. And then last but not least, we have this -2 at the front, so it's kind of does a lot of stuff together. So you want to think the minus reflects it. So the minus in front reflects over x-axis, and then because there's a 2, stretches it. Stretches the graph. So this would be one that it would look somewhat like this. It would go down. So we can see that real quick on Desmos, that if I had a -2 in front, we see that now it's on the bottom and it's actually more steep, so it's been stretched. Okay. So a lot of this is just how you stretch and so forth, and it kind of gives you a nice summary here, right? One thing to note, it will start combining things, right? So take it one step at a time. What do you notice? There's a -3, right? So that means we do what? We're going to, so always start from the X and work your way outward. So the first thing you're happening to the X is you're minusing 3. So that means I'm going to go right 3. That's the first thing that happens. The second thing, you'll notice there's that minus in front. So you're going to reflect over x-axis, And then last but not least, you're adding the 1. So you're going to go up 1 unit. Okay. I would always check with Desmos as well. Okay. So check Desmos. And there's a match problem here. It wants you to look at these two and kind of decide what's happening. This can be difficult. Okay. So what do you notice? So take a stab at this, but one thing I will say is that this did not go with the problem here, because it's a visual thing, but you'll notice that instead of going looking like an S, it looks like the S was flipped, kind of, or this sort of shape. Not really an S, but you get the idea. And then we have to do what? It looks like we move to the right. Okay. The last part for this talks about piecewise defined functions. Okay, so piecewise means instead of writing a function a certain way, I can break it up, and for certain values of the domain, I have different rules or different functions. So I can, so for instance, absolute value, if x is less than 0, I have to switch the x. And then if x is greater than 0, it's just the same, because absolute value, it doesn't change it if it's positive. Okay. Now, for Desmos here, I think there is a way to do this. Let's see. If I do f of x, and I do equals, and then if I have this, can I do it? Let me see if I can. I'm pretty sure there is a way, and if there is, we will talk about it in this video. Let me. So let me go to this real quick. Google is your friend. So, for a lot of things you're doing, like for instance, we don't really do piecewise that much. So piecewise functions in Desmos. And for some reason, so this is one of the things that it's doing here. All right, so it looks like you'll notice in Desmos, this is an example of a piecewise function. It's a little complicated to do, but I'll show you what you can do for this. So if you want to do it in Desmos, since I kind of got the general idea, right? So y equals, and then you have to do your curly bracket, and then you have to put your domain restriction. So in the piecewise function, it has the function value and then the domain restriction, like written in the notes here. So we'll say that, for instance, this is your function rule, and this is the domain restriction. So in Desmos, you have to put the domain restriction first. So I would have to say x is less than, let me see. No, why did it not? Okay, x is less than 0. And then we do okay, so I'm going to turn the other stuff off. So we see now we just have a line here and so forth. So you could do whatever you'd like. So it's the main restriction and then the other thing. So for the absolute value, it was negative x there. And then we have to do y equals. And we would say x is greater than or equal to 0. Bracket x. And voila, we have absolute value here made up of two pieces of two separate functions. Okay. So remember, for Desmos, it's the domain restriction, and then you got to do these curly braces, domain restriction, colon, and then the function. Okay. So you'll see here, for instance, this first one, you'll notice the right side is not there. It's phased out. Why? Because this is saying I only want to see this when x is less than 0. So I don't even need to see when it's greater than 0. So this is not there, okay? And likewise, for this function, I'm only defining it for x is positive or equal to 0. So I don't want to see the left side. So I can combine these together into one function that's made of separate pieces, so it's a piecewise function. And you might wonder, how do I evaluate this? So for this one here, if we say that this is f of x equals So you think, if I want to do f of 0, which one do I pick? Does 0 work here or does 0 work here? It works in the second one. So that means f of 0, I'm going to use the second thing. So it'll just be 2 in the end. So when you're evaluating, you want to check which domain does it work in, and then you use the rule associated with that domain. So you have an example here for this graph. So I would highly advise you could check with Desmos. Okay, so if you're going to write this in Desmos, okay, you could type in the following. Oops, don't want to have that. And we'll type this in a moment. Let me just write this down. So you'll have 2 separate lines for each piece, okay? Okay, so let me take a picture of this, and then we can scoot over to Desmos and see what it looks like. So let's go over to Desmos. All right, so let's type this in. So g of x, right, equals curly bracket. Remember, you have to put your domain restriction first. So 0 is less than or equal to x is less than 2. And then you put your colon, which is right here on the bottom. Okay. And then you type your equation in for that domain part, for that restriction. And what do we notice? It's already filling in for us right here, right? From 0 to 2, we see this tiny little line. For the next one, we want to do the same thing. G of x equals, and then do your curly, too soon. Do your restriction first if x is greater than or equal to 2. And then remember, you do your colon, and then type in your equation, 0.5x. If you want to put a 0 in front of the decimal, that's fine too. And then we're going to close it. So you'll see here, this is my piecewise function. So you could graph this if you want, or you could think that, okay, if I'm doing multiple choice, like for a homework question, I can kind of figure it out which one I would pick. So Desmos. Okay. You have a match problem here, you can use Desmos. And last but not least, you have this example here. So you have this utilities, okay? So it says write a piecewise definition for the cost of consuming X of natural gas and graph the function. So you might have a similar thing in your project that is like your taxes. Okay, there's a tax example. It might be in the homework as well. It wants you to graph it, and then there's a match problem. So one thing to note, this is a piecewise function. So you pay this much for the first 5, right? So your f of x. So we know for the first 5. So, right? And then after that, for the next 35, so we have to figure out what would the rule be here. And then for the next 35, that means we have to go to 40. And then if we're over 40. So we have to figure out what would the rules be. So let's look at this information that we have. So for the first part, it's this much cents per CFF, right? So then it would just be however much I have times X. And then if we're over, for the next 35, it's a little bit cheaper. But remember, I've already paid for what? I've already paid for 5. Okay. So I have to figure out how much was it for the first 5. So just multiply 0.7866 times 5. And I get 3.933 plus. And then it's however much I have over 5. So that would be X minus 5. So remember, I've already paid for the first 5, so I'm not going to include them in the new rate. So for instance, if X is 6, I only have 1, which is from this part, that I would pay because 6 minus 5 is 1 at the new rate, and the first 5 I've already paid for. Okay. And then last but not least, I'm going to do something similar for the last part here. How much have I already paid for if I'm at 40? Well, 5 was at the first rate, and then 35 was at the second rate, so I need to figure out what that combo would be. So it's very similar to tax brackets, okay? It might be hard to wrap your mind around it at the beginning, or if you've never actually done taxes or filed taxes, that can be confusing, let me tell you. So if I take how many I have paid for from the first 5, and then the next 35 at these two rates, so the first 5 at this much at 0.78, the next 35 at 0.46. Okay. And I'll double check that really quick. And then the last ones, how much I have over 40, it would be X minus 40. Okay. And then you could get a graph by using Desmos for this. So hopefully this example was useful. You'll see here, like for these at the end, it does go through it, and you'll kind of notice what, when you look here, this one does, over 200, 150, 50. And you'll notice it does a very similar setup that I just talked about. For the first part, and then if you do all 50 at this is how much you pay. And then you have the different rate for anything after 50. And then last but not least, this is the combined total of the first 50 and the next one's 50. And then you have a different rate for what's after 200. And then just get used to Desmos. Maybe see if you can get the same graph on Desmos. So if you do have any questions, let me know. Thanks again for watching.